Hi everyone, I'm Dr. Season and welcome to our course, Thermodynamics.
Today, we're going to discuss temperature. Heat and temperature are two different concepts but are related to each other. Temperature is usually associated with heat. The difference between heat and temperature is often confusing, that it has been a source of misconceptions among students, especially in the way the terms are used. The heat content of the body will depend on its temperature, its mass, and the material it is made of. Heat energy is always transferred from an object at high temperature to one at a lower temperature. Temperature is not the same as heat. Temperature measures the degree of hotness of a body. It doesn't depend on the mass or the material of an object. Temperature is also related to the random motion of the molecules in a substance. It is the average translational kinetic energy of molecules. It is not a measure of the total kinetic energy of molecules in a substance. In relation to heat, it is defined as the property that determines the transfer of heat energy to or from other objects. Between two objects, the one with the higher temperature is the one that transfers heat to the object with a lower temperature. If no net transfer of heat occurs between objects, then the objects are said to be in thermal equilibrium. Thus, the objects have the same temperature. From table 2.1, we can see the temperature scale comparison. Water boils at 100 degrees Celsius. For Kelvin, it is 373. In degrees Fahrenheit, it is equivalent to 212. Water freezes at 0 degrees Celsius. For Kelvin, it is 273. In degrees Fahrenheit, it is equivalent to 32. For absolute zero, it is negative 273 degrees Celsius. For Kelvin, it is equivalent to 0. And for degrees Fahrenheit, it is equivalent to negative 459. The instrument used to measure temperature is the thermometer. In measuring temperature, the thermometer must be in thermal equilibrium with the object with an unknown temperature. The device can be a thermometer if it makes use of some physical property that reacts to changes in temperature. These are called thermometric substances. The common thermometer consists of a glass tube with a thin column of colored alcohol or mercury. The change in length of the liquid inside the column is proportional to the change in temperature. Determining the object's temperature with precision requires a standard measurement. These standards often use temperature scales. These are three main temperature scales used in the world. Number 1, degree Celsius. Number 2, degree Fahrenheit. And number 3, Kelvin. The temperature at which ice melts, water freezes, and the temperature at which water boils are used as reference points on both Celsius and Fahrenheit scales. From table 2.1, the freezing point of water is 0 degrees Celsius on the Celsius scale, and the boiling point of water is 100 degrees Celsius. Water freezes at 32 degrees Fahrenheit on the Fahrenheit scale and boils at 212 degrees Fahrenheit. On the Celsius scale, there are 100 degrees between the freezing point and the boiling point of water, compared to 180 degrees on the Fahrenheit scale This means that 1 degree Celsius is equal to 1.8 degrees Fahrenheit. Thus, the following formulas can be used to convert between the two scales. Next thermometric scale is the Kelvin scale, or the absolute temperature. This scale, which is named after Lord Kelvin, is based on one fixed point, the triple points of water. The triple points of water is the temperature at which saturated vapor, pure water, and ice all coexist in equilibrium. The Kelvin equivalent of a degrees Celsius measurement can be found using this equation. Kelvin is equals to the temperature in Celsius plus 273. Celsius and Fahrenheit can have positive and negative values, but Kelvin is always positive. Kelvin is considered to be an absolute scale. Since temperature is associated with kinetic energy of the atoms, which is positive, the absolute temperature should be positive also. In the Kelvin scale, a temperature of 0.0 Kelvin indicates the lowest temperature, which the molecules have zero kinetic energy, which is equal to negative 273 degrees Celsius. The intervals of both the Kelvin and Celsius are the same. It also follows that changes in temperature will be equal for both scales. Now let us proceed to problem solving. Number 1. A container with oil is heated from 40 degrees Celsius to 120 degrees Celsius. Find the change in temperature in degrees Celsius and Kelvin. From the problem, we have the following given: the initial temperature 40 degrees Celsius and the final temperature 120 degrees Celsius. From our solution, first we have to find the change in temperature, and that is delta T, or change in temperature, is equals to 120 degrees Celsius minus 40 degrees Celsius, and that is equivalent to negative 80 degrees Celsius. And finding the temperature in Kelvin, we're going to use the formula for Kelvin. Kelvin is equals to temperature in Celsius plus 273. Since the initial temperature is expressed in degrees Celsius, you have to convert the temperature in degrees Celsius to Kelvin using the formula for Kelvin, which is Kelvin is equivalent to the temperature in degrees Celsius plus 273. Since the given are the initial temperature expressed in Celsius and the final temperature expressed in Celsius, you have to convert this temperature in Kelvin. So we have here the solution. The initial temperature is equals to 40 degrees Celsius plus 273. Therefore, the temperature in Kelvin is 313 Kelvin. That is for the initial temperature. And for the final temperature, we have 120 degrees Celsius plus 273 is equals to 393 Kelvin. Now, to compute for the change in temperature in Kelvin, we have T sub F minus T sub I is equals to 393 Kelvin minus 313 Kelvin is equals to 80 Kelvin. That's all for now. Thank you and keep safe.